Hi, I am Swami Savan. Now I will be demonstrating the lab assignment, which was to create a dashboard for the Iris dataset. And regarding the Iris dataset, we all know that it is a very famous dataset, and we can see the data in the console. It has four features: sepal length, sepal width, petal length, and petal width, and there are three types of species. So I started with plotting. So I started with plotting the clusters. Like there are three species, so I created three different clusters for each species. And as you can see that for the four variables, these are the dynamic layout for selecting different variables. And we can see where the cluster is the where the more number of clusters are balanced by checking the bar plot count. We can we can see like for the petal length and petal width, there are 48, 50, and 52 clusters. It is very ideal situation because in reality also there are 50, 50, 50 distributed. So we can check that this is a cluster, a single cluster, and all the species are in the same cluster. These all are Setosa, and these all species are unique, and the green one is a different. So clustering is actually working fine for this petal length and petal width. We can check manually for all the variables for all the 4C2 combinations. And this is the combined scatter plot for a overview of the visualization in which variable versus which variable we can visualize the cluster. And this is the density plot. Density plot is fairly simple. For every variable, we can see the count like the bin range 4 to 4.5. We can see how much data is distributed in that bin. So for sepal width also we can see, and all species combined we can see that it is 50-50-50 because 150 data points are in the Iris dataset. And at last, I did something unique: KNN cluster prediction. Using a very simple algorithm, K nearest neighbors, I tuned the hyperparameter to 3. I set the value of hyperparameter to 3, like it will take the mode of the 3 nearest neighbor in of this 4D data provided. See, it is giving a prediction Sitosa.